Hi everyone, I didn't realize my mic was hot. That's good. So thanks for coming. My name's Damian Brady, and today we're going to talk about you, and specifically what makes you happy and how to make you happy, but more importantly, why your workplace should care and how to make them care. Yep, it's not working. So who here is a dev? Put your hand up. Oh, it was in the keynote. Most of you should be. So are you happy? Actually, no, don't answer that. That's a bit deep. Think about the last day you actually went to a real work rather than a conference, right? At the end of that day, did you feel like that was a good day? Were you productive? Who walked out that day and thought, good day? All right, that's less than half, which is not great. What about for the people who didn't put their hand up? Did that happen sometime in the last week, maybe? And nobody else put their hand up. All right. For those who did have a good day, have you thought about why and what it was that made that feel like a good day, like a productive day? So your happiness obviously matters to you, but we're going to talk a little bit today about why it should matter to your company as well, and then what they get out of it as well. Because, let's admit it, traditionally, companies don't really care whether you have a good day or not. What they care about is your productivity. Have you done the stuff that you are supposed to do? And traditionally, companies measure that productivity by looking at the inputs versus the outputs. Right? So how much did it cost for my human resources to produce a certain amount of output in the day? And that's kind of the traditional measurement of whether somebody is productive or not, or whether an organization is productive or not. And you want that to kind of go above the line of costs to productivity, essentially. But in development, that often boils down to these metrics that don't make a lot of sense in that context, like lines of code or number of commits or number of pull requests raised. And these metrics can be easily gamed for a start, but also some of the most valuable work you do as a developer does not result in new lines of code. In fact, it might result in far fewer lines of code in your code base. So I've certainly worked in organizations where we're measured on lines of code produced, and it's a terrible measurement ultimately for productivity. So then if these traditional methods of kind of measuring your productivity are terrible, what are the good ones? So there was a really good piece of work done by Dr. Nicole Forsgren at Microsoft Research, came out of Microsoft Research, called the SPACE framework. Now this is a way of looking at all the dimensions that affect productivity, essentially. So I'm not going to go into it in too much depth. There's a link down bottom left if you want, but if you search for SPACE framework, you should be able to find it fairly easily. But ultimately, if you're trying to measure and track productivity in your team, it's more than just activity metrics, which is the A in here. You also need to care about people's satisfaction and their well-being, because that contributes positively to the productivity, like the actual stuff that you get out the other end. Performance is to do with how good the code they produce is, how high quality it is, and if you're doing all this work, are you actually producing good, valuable work at the other end? Communication and collaboration kind of goes without saying, and activity, of course, is the lines of code and pull requests and things. And then efficiency and flow is about your systems that put it all together. But we're talking about happiness, right? So I want to focus on a couple of these in particular. That first one, satisfaction and well-being, that one is all about, it's closest to happiness, right? It's, are you satisfied in your job? Do you feel like you have contributed? It comes back to the question before, did you have a good day? If you have a good day and you walk home and say, I completed the things that I wanted to complete, I made progress, then that gives you satisfaction. Right? And that gives you well-being in your job, and it leads to better performance. That's part of what this framework is. But why should a company care if you're satisfied? Beyond, you're not going to complain and go on, I was going to say another website, but go on different websites, Reddit, complain about your company anonymously, things like that. Beyond that, why should they care? Well, the research that I'm going to show you in a sec basically draws a direct correlation between the happiness of employees and the performance and the productivity of that organization. And there's even a correlation all the way through to how much money your company makes, if that's their goal. Let's look at the last one as well, because this one's really important, efficiency and flow. This is basically how easily you can do your job. So are you constantly context switching or waiting on other teams and other team members to be able to do your job? This is part of research that's come out of a bunch of different places, but one of my favorite places is work by Gene Kim around the 3 ideals of DevOps. And one of them is the idea of focus, flow, and joy. 5 ideals, sorry. 3 is the other one. 5 ideals, focus, flow, and joy is my favorite one, which is basically if you can focus on a task, you enjoy doing that task, you actually get into a flow. We know about flow states in development where you can focus, you can get really good work done. So this efficiency and flow and the efficiency of systems and being able to have locality in your work so that you don't have to keep going out somewhere else, losing the context of what you're working on to go and wait for the database team to spin up a test database and things like that. This all contributes to productivity as well. Now, obviously, it follows that efficient systems are going to lead to more efficient processes, and therefore, the outcomes are going to be better. But I want to put this in kind of real terms, and this is something you can take to your bosses as well. Imagine you're in an organization with about 100 developers, right? And the efficiency of the processes mean that for every hour that you used to work, it now only takes 55 minutes to do that same level of work. In dollar terms, can anybody guess roughly what that means? And when I did these calculations, by the way, I went to like the average salary of a developer in Denmark. It was America, but that like skewed the data way out. They get overpaid. Denmark, average salary in Denmark, 37-hour week. Sorry again to the Americans, there's a 37-hour work week here apparently, and 5 weeks of vacation that everybody gets. Is that right? Cool. I'm going to cancel my return flight. So at 5 minutes every hour saved, what do you think that means monetary terms in an organization with 100 developers? Is anybody willing to shout out a guess, realizing where I am in the world? Yeah, you saw the slides, so you can't guess. All right. It's about 3.775 million kroner. But that is purely salary cost, right? That ignores any benefits from having happier developers for a start because they're not fighting the systems all the time. And it's also ignoring the very real cost of having to retrain people when they get frustrated with the environment you're in. So there's a lot of retention that comes up as well with better, more efficient processes and happier developers. So this is all productivity though, and the title of the talk was happiness. So I'm going to delve a little bit deeper into happiness and what that means in the context of development. So I work for a company called GitHub. Has anybody heard of GitHub? Yep, a couple of people. So we have an advantage, a unique advantage in GitHub where we are our own customers. And it's not all good. There are some cons to that situation. But what it means is if we improve our systems, if we improve the way that we work, we're improving the way that a whole bunch of developers work. And that ultimately leads to a better product that we can start selling to other customers. So the term is usually dog fooding, but apparently I'm supposed to say we drink our own champagne, which is much nicer. And we use the tools that we create, and we use the same tools that we sell to other people. So GitHub uses GitHub to write GitHub. There's actually a really good talk from, if you have a look, this year's Microsoft Build that was done by Martin Woodward, who's my skip, and Neha Batra, who is one of the VPs in engineering, about how GitHub uses GitHub to write GitHub. Ultimately, what it means is we are constantly trying to improve the way that developers' lives work from day to day. And we call this thing developer experience, which you may have heard of. This is kind of core to all the stuff that GitHub does. It's usually abbreviated to DevX, or often abbreviated to DevX these days. By the way, at the end of October, there is a GitHub Universe conference in San Francisco, but you can watch it online as well. And one of the 3 kind of pillars that we're basing the entire conference on is DevX, developer experience. There's also security and AI, because those 2 are obvious. But developer experience encompasses everything that happens to a developer day to day. Ultimately, it describes how developers work, including things like the systems and the processes that they use and the value that they have for their own work as well. So you don't want to just write and ship code as a developer. You want to write and ship code in an environment that's optimized for writing and shipping code. So that's what we're trying to get to by improving developer experience. Now, back in 2021, we do this State of the Octaverse every year where we look at the data from GitHub and tell you some trends and things like that. Back in 2021, one of our researchers, Irini, she was part of this project called the Good Day Project. And ultimately, it was mapping self-reports of whether you had a good day, just like the question I asked before, to GitHub activity. And things like how many meetings you had that day and that kind of thing. Looking for trends in what made a developer's day good. And the findings were really interesting, probably going to resonate with most people who are developers. But there are a few really interesting things. So one key finding is that developers, to be able to feel productive and have a good day, they need deep focus time. So blocks of time where you can focus on the one task to get it done. And that makes you feel productive. Right? The likelihood that a developer will make progress towards the goals that they need to make progress to depends a huge amount on how much focus time they can actually get, how much of this deep focus time you can get. And you can actually quantify this, or they quantified it in this study. So who loves meetings? Nobody's hand went up, that's weird. So in the study, we found that going from 2 to 3 meetings per day lowered the chances of developers making progress towards their goals. But it's quite striking how much it affects it. So on average, if developers have 1 meeting in a day, we found that they were 99% likely to say that they had made progress towards their goals at the end of that day. It was a good day, I made progress with 1 meeting. When you give them 2 meetings, it goes down to about 75%. When you have 3 meetings in a day, that goes to about 14%. So it plummets. As soon as you have to do 3 meetings in a day, so the secret is not, is not to have more meetings, right? That's not going to improve things. What if you have 10 meetings? If you extrapolate, I'm not great at statistics, but I believe it's well into the negatives at that point. You hinder other people's progress at that point. So it's really about getting this deep focus time and being able to do the work. Because interruptions, of course, are the things that stop you from doing that focus time. Now, we've all heard about getting into the flow, and breaking out of the flow means that it takes you X minutes to get back into it and all that kind of stuff. But it turns out they could quantify that as well. And I just realized I'm going to spoil it because there is a slide, an animation that I left. So let me just see if I can. So the graph is, did you have a good day? Like what percentage of people said they had a good day versus how many interruptions you had. And they really just categorized it in terms of, did you have basically no interruptions, or did you have several interruptions during the day? And I'm just going to skip through this because I got the animations wrong. If you had minimal or no interruptions during the day, 82% chance that you're going to say, I had a good day. And that's 7% if the majority of your day was interruptions. There's my animation, that's great. So in other words, like the more interruptions you get during the day, the less likely you are to say this was a good, productive day. The more meetings you have in a day, the less likely you are to say, I've made progress towards my goals. So that was really interesting as well. The effects of this kind of stuff are really real. This is not the only piece of research that's been done around this as well. One of the other ones that I love, and actually went quite deep into this one, and so hopefully it'll be worth it, is back in developer experience, the broader term of everything that we do. So this was from January this year. They released the results of this, and this is a study including Irini from our GitHub Next research team as well as her Nicole Forsgren, who I mentioned really early. who's at Microsoft Research. Now, the study was fascinating. I went down a massive rabbit hole on this, but they basically looked at software development through the lens of something called work design theory. And so work design theory looks at the work that people do, in this case, the work that developers do, and how that affects outcomes, not just individually, but for their teams and for the organization. They looked at 3 of the most important dimensions when it comes to software engineering especially, which is, and these are things that affect developer productivity, so flow state, which we've talked about a bit, feedback loops, and the last one was cognitive load. So I want to talk about them a little bit more as well. Flow state we have talked about. It's basically being able to focus on the work that you're doing as well. So they found that enabling a flow state or having an environment that enables developers to get into this flow state has positive impacts not just for individuals but for the team and then for the organization. So if your developers are able to focus on their tasks, your organization meets its goals more often, which is telling. Feedback loops are all about outputs from one part of the system being used as inputs to another part of the system. So for example, if you have automated testing, right? If a test fails, that is input that works its way into the next part of the system where you find and fix bugs, right? That feedback loop, if those are improved, that has huge benefits as well. If you've heard me speak at other NDC events or any other events as well, there's a very good chance I was banging on about DevOps. Feedback loops and the speed of feedback loops and the quality of the data you get from feedback loops is a really common topic in DevOps as well, but generally in software development, right? Good feedback loops give you usable information with a really tight time frame so you can act on it immediately. Right? The last one though is called cognitive load, and this can get a bit complicated, but I'm starting to really love this topic. It's all about how much effort it takes to do the thing that you need to do. Now, in work design theory, they define 3 different types of cognitive load. There is intrinsic cognitive load, which is actually doing the task. Extrinsic, which is retrieving information and the format that information comes in and how understandable it is. And then there's germane load, which is processing that information, organizing it into schemas in your brain so that you can use that information to perform the tasks and how difficult that is. So for example, to put it in concrete terms, because we're all developers, imagine you have an online shopping site and you've been asked to add a suggested purchases section. So you bought these things, how about you buy these ones as well? So that's your task, right? Intrinsic load is the actual difficulty of writing that code. Typing the keystrokes, opening the files, getting the right files open and making the changes to the code. There is inherent difficulty in some of that, right? Extrinsic load is about getting the right information. And that can include things like having a look through the code base to find out if there's any code that we can use that already has suggested items based on other ones. And if not, how do we get the data out of the database to find that information, right? Where does that live? Even things like, how easily can I find the files that I need to edit that are related to this change? All of that is extrinsic load, how difficult it is to find that information and how it's presented to you. And then once you have that information, germane load is the processing of all of it so that you can actually perform the task, keeping it in your head in a known format. So how do I internalize where all the code is that I need to change and how it fits together, along with the solution that I've come up with to solve that particular problem. And that can be difficult as well. So these 3 areas, and I'm going to go into some of the kind of solutions for making these better later, but these 3 areas, flow, feedback loops, and cognitive load, have effects on productivity across individuals, teams, and organizations. So flow is strongly correlated with all of them. If you can let your developers get into flow, there are benefits across the board. Feedback's correlated with teams in particular. So this is according to the data, right? Team outcomes are positively affected by good feedback loops. And then finally, cognitive load, reducing cognitive load, making it easier to perform the tasks, is associated with all 3 of them as well, quite strongly. So all of this theory basically says these things are important, right? And we've seen before things like flow and reducing cognitive load, obviously, and feedback leads to developers feeling happier, right? But I mean, what do we actually do with this information is the next question. Right? So we have all this research. What does that mean in practice? So let's talk about getting into a flow state. And that good day project that I spoke about, that gives us some good ideas for getting into the flow and reducing interruptions. So we'll go back to that question about people who had a good day. Is this starting to resonate that that good day was probably influenced by the amount of time that you spent in that flow state, right? I'm seeing a few nods, but I want to do the hands thing again. Who said that they had a good day very recently, sometime in the last week? Okay. Keep your hands up if you had some significant deep flow time. Yeah, basically almost nobody put their hand back down. Some people put their hand up at the second part of that question, which makes me think they weren't really listening. So that good day project gives us some good ideas about what we can do to get rid of these interruptions. Right? So practically, some things that you can do to reduce interruptions and allow you to have that flow state. You can start with discouraging ad hoc interruptions. Who here works in an office again after post-pandemic? Okay, that's actually quite a few people. Does anybody have that practice in their office where you have headphones and you just put your headphones on? You might not actually play any music, but it sends the signal to the rest of your team that you're busy, you're doing something right now. That actually seemed like a toxic thing for a while in the organization, but I think a lot of that depends on the culture of that organization. So if your organization understands that when you have your headphones on, that means you are focusing on a task, and that they have an idea of the value of having that focus time, that flow, then that becomes a very positive thing in your organization. Having a set of headphones on means don't interrupt this person unless you need to. I've actually worked in organizations where we had a physical sign on the desk, and if you turned the sign a particular way to say, "I'm working, please don't interrupt," it was knowledge inside the office that you don't interrupt that person. They're busy at the time. So those kinds of ad hoc interruptions, they're relatively easy to prevent as long as you work in an organization that sees the value and listens to your little sign or your headphones. But these days, a lot of us work from home, right? And the interruptions, if you have them, are from people who don't understand that you need this focus time and that you need to work. I have two young kids. I have a 4.5-year-old and a 6-year-old, and they don't really listen to the headphone rule or the sign. They can't read. I guess that's probably one thing. But what it means is those kinds of solutions require closed doors, locked doors, things like that. The other types of interruptions that you get, though, are largely self-driven. So well, I know the answer for me, but who last time they were writing code, who had like Slack or Teams or something open, another monitor? Yep. Email open another monitor, their phone next to them, buzzing with notifications and things like that. Guilty. There's a lot of people like awkwardly nodding. This is an opportunity for you to improve that focus time by being self-directed. Now, I'm going to be the first to admit I'm pretty terrible at this. I will usually leave most of that stuff open. But if there is a period of time where I need to focus, I will turn on Do Not Disturb mode. And most machines have that kind of thing, like a Do Not Disturb, which is what my laptop's on now. Or Windows, I think, has it's Do Not Disturb as well. Okay. And that means that you won't get the notifications in general. Some apps ignore that, but in general, you won't have them. So you can close Slack as well. You can close Teams. You are able to do these things and close those to give yourself the focus time. I'm not great at that, I'll be honest, but it is extremely helpful. Right. What about meetings? We can't just say, "Oh, hey, I'm not doing meetings this week." It's not a feasible thing if you work for somebody else, right? Does anybody's calendar look a bit like this? Yeah, so the audience is split in half now between people who are like, "That looks horrible," And the other half are people who are like, oh my God, I wish I had a calendar that was that clean, right? I don't want you to notice so much the number of colored squares in this. There's 21, by the way. I don't want you to notice how like the colors so much. I want you to notice the distribution. One thing that you can feasibly do, which I like calling calendar ops, is to defrag your calendar, right? This is still 21 blocks of meetings. It's the same number, but now we have these blocks of focus time. Now, the people who are sitting there who were the ones who said, I wish my calendar looked like that before, are probably looking at this thinking, there's zero chance that I can do any of that. Yeah. There's often some meetings that you can request to be moved, often. So this really does depend on your company, your organization. If you're in a dev team and you have your stand-up at 11 a.m. every day, that's a terrible time to have it, because you're necessarily like blocking, interrupting that block of time. If you can say, on Wednesdays I don't have meetings, and let's move them all to other days, at least you have that one day of the week, which is unblocked. You can do that, you can have that focus time. So this isn't always possible for everybody, and it's not always possible to a large extent for a bunch of people either. But it's worth trying. Move some appointments around so you have blocks of meetings and blocks of focus time. All right, where are we at? Let's talk a little bit about cognitive load as it relates to software development, especially. So I talked a little bit about intrinsic, extrinsic load, and germane load, those three different types. Context switching is just a thing that we have to do in software engineering, and it has a huge impact on the cognitive load of doing a particular task. So, for example, you are halfway through a piece of work and somebody comes and asks you a question about a component that you wrote last week, right? Immediately, everything in your head, like the germane load where you've loaded everything up, you know what you're thinking about, all of that falls out of your head and you have to build that up again, right? Intrinsic load about writing the code, if you change the work that you're doing, you're now in a different file, you're now working with a different set of libraries. Actually writing the code is a little bit harder. The extrinsic load about finding information, well, now the information is completely different. You're working in a different part of the application, or you're working on a different project or something like that. In particular, cognitive load is affected by extrinsic and germane load, though. So if you have to continually go to other tools, to context switch, to look at other tools, to find information, that increases the amount of extrinsic load that you're experiencing. So if you need to go and look at your company's documentation to work out how to use a particular library, and to do that you go through the browser or another application, that's adding load that you might not have otherwise needed. Germane load as well is affected by how that information is presented. So if your docs suck, then you're probably going to have more trouble processing that information and storing it in a way that you can use. So think about the last time you were deep into a solution for a coding problem, right? You hold a lot of that information in your head, and the structure of the code, the intricacies of what solution you're going to implement, and how all the objects relate to each other and things like that. And then you need to go and look something up and still try and hold on to that information in your head. That kind of behavior is something that we do all the time, and it increases that load. So any of those tools that can kind of help you stay in that flow of doing the work are hugely beneficial. All right. We'll talk about AI tooling soon. I've got so many slides in and I haven't said AI once yet, so I hope you're as proud of me as I am of myself. But those tools are all designed to reduce the extrinsic load and even to some extent the germane load as well, and make it easier to find the information that you need to perform your task. So for easing, let's talk about extrinsic load for a start. Let's talk about intrinsic load for a start, like the work of actually writing the code. Right? One of the ways you can improve that is to learn your editor. So I use Visual Studio Code, and there's a bunch of features that editor has that are worth learning. Like right here, I'm using multiple cursors to be able to change all of the instances of ID to something else. that means that I'm doing less actual work to implement the change that I want to implement, right? It also helps, learning your editor also helps with extrinsic load, finding the information you need. So being able to right-click on a symbol and say go to definition, that's much, much easier than opening a browser window and going to the documentation and trying to find that thing you're looking at, right? And some of the tooling that we've got in recent years, last 10 years or so, things like autocomplete and like dot completion and things like that, that's reducing the extrinsic load. It's looking things up for you that you otherwise would have had to go and do yourself. It keeps you in that flow. So learning those tools is really important and can help with that, with reducing that load as well. So learn the IDE. All good IDEs have this kind of stuff. If you really want to be smug about what your IDE can do, you can learn Vim. I hear that's the entire reason people learn Vim, is to be smug. But sometimes you still need to context switch, right? You still need to go out and find more information, or look for some files, or look for some documentation, right? And again, good tooling can help with this as well. So at GitHub, one of the things that I've heard the engineering teams talk about especially is this idea of dev day zero. So when I don't know about you, but maybe this is going to date me, when I did my first programming job out of university, I started at a government organization, and I think it was about 3 weeks before I could write my first line of code. I mean, initially they didn't even have a machine for me, which I don't know what type of cognitive load that is, but I didn't have anything that I could physically write on. So they gave me a folder full of documentation and asked me to read that. Even when I did get the machine, towards the end of that first week, actually getting it to a state where I could write code was a chore, right? They had a system there, which I don't recommend, in Windows, where you had 3 user accounts, or you had 3 accounts that you had to use. There was one which was your admin account, so you could install software. There was another account, so you had to log out and log back in to do your development, which had some local dev privileges, but you couldn't install software. And then you had a third one, which gave you access to the internet. So think about the extrinsic cognitive load of being in an environment, this is a bit of an aside, but an environment where you're like, oh, what was the name of that function again? I'm just going to log out of Windows and log in again under a different account so I can do a search. No, I'm not joking at all. They also banned the use of like run as, which you can do in Windows, but they banned the use of run as, and then everybody did it anyway. So anyway, the point was that it took me a long time to be able to actually write code that would ever make it in production. It was weeks before I got my hands on the code base, because the machine needed to be set up as well. All the libraries that we used, all the dependencies, all the frameworks, all of that stuff, none of it was installed on the machine when they gave it to me. So it took a long, long time before I could actually write code. Just while I take a drink, has anybody else had that situation? I'm expecting more of the old people to say, not all of the old people. So the idea of dev day zero, I heard about at GitHub, which was basically when a new developer turns up to write code, day zero, essentially, the first day, and zero-based, obviously, day zero, they should be able to write code that can make it into production. And the way they did this was a technology basically where the machine that you have is not the machine that's running any of the code. Now, was anybody in Chris Ayres' session the last session? A couple. He talked about code spaces. So this is what this project ultimately became, was a product called GitHub Code Spaces. So essentially, instead of having your dev machine have all the code on it, and then you have to install all your dependencies and things like that, you have a definition of a machine that can get spun up in the cloud, you do your work, and then you tear it down. If you do something wrong, and you realize that this implementation that you've just spent the last hour on is not going to work, sometimes it's just easier to turn the code space off and create a new one. Now, this idea of disposable environments, it's not just GitHub code spaces or dev containers if you want to use that locally as well. That's not the only solution to this. Windows has Microsoft has DevBox as well, which is the same idea of a definition of a machine that you need to use that runs in the cloud. It has a bunch of other advantages too. So for one thing, you can hand anybody any laptop, and as long as they can log into GitHub, they can start doing their work, right? So if you drop your laptop and smash it and get another one, you can be back up and running really quickly. It also means that everybody's on the same environment. My environment that I'm coding against looks exactly the same as yours. So everybody's working to the same thing. It also means onboarding takes far less time. When you get a new developer, when we started doing this, by the way, at GitHub, the onboarding time to be able to write some code went from about 45 minutes, which was very optimistic, to like less than a minute. I don't think I'm allowed to do it on a recorded one, but if I opened up the GitHub directory, which is about 70 or 7 gig or something, it's big, it's like a lot of code. If I opened up that repo and created a code space, I could have GitHub running in that environment inside a minute. And that's letting me debug, letting me write code, make changes. So that advantage for new staff is really good. But it also really, really helps with this idea of context switching. So if I'm halfway through a task and I'm like, oh, I need a break, I might do a code review from this pull request that somebody else opened a little while ago. I don't have to unroll the changes that I've made or commit them to a branch and then come back to it later. I don't have to worry about the environment itself. It could be on a different project entirely. I just turn my code space off, open one with the context of that pull request, do the code review, and then tear it down again. Now, there's not no cognitive load to that. Obviously, I'm switching tasks, but the tooling means that it's a lot easier to do. So that being able to switch a task and have an entire development environment set up for each one and being able to switch between them is hugely beneficial for this cognitive load. Right? It makes it easier to move from one task to another. It's also really good for contributing to open source. So if you want to contribute to like Home Assistant or something like that, if you use that project, you can just spin that up in a code space and everything is ready. You can get ready to debug straight away. So the cost of doing that work is much, much lower. All right, I got to slide 39 before I talked about an AI tool. So I'm proud. Tools like GitHub Copilot. Who uses GitHub Copilot, by the way? Okay. Who uses a different AI programming tool? Who uses just ChatGPT? Yep. There's not as many as I thought, actually. Okay, that's good. Now these tools, these AI tools, are, at their core, designed to reduce cognitive load. Right? Whether that's intrinsic cognitive load by doing things like suggesting the next lines of code that you're going to write, which is the original kind of ghost text copilot that we always advertise, or whether it's helping you understand. That's the purpose of these AI tools, or it should be the purpose of these AI tools. The other purpose, of course, is to put AI in your product name so you can make more money. So the current AI tooling helps a huge amount with intrinsic and extrinsic cognitive load. So it's presenting the information to you really easily, but it's also helping you like reduce the number of keystrokes. You leave a good comment about a function you want to write and it suggests the entire function. It now just takes you looking through to make sure it's okay and hitting tab. So the intrinsic challenge of actually writing that code goes way down. But some of the newer stuff, like being able to highlight a chunk of code and say to Copilot Chat, can you explain what this code does? That's dramatically reducing extrinsic load and even to some extent reducing the germane load, being able to process that information. If I can just ask my AI tool to explain this for me, that makes things a lot easier. Right? It's incredibly beneficial in terms of developer happiness, which is one of the things that we kind of pushed as the reason to use some of these AI tools. But you also need to know how to use them. And so we come back to learning your editor, being able to learn how these tools work so you can get the most out of them. So, what do we do? Yeah, so extrinsic and intrinsic load is dramatically helped. But as we move a little bit closer to smarter and smarter AI tools, we're going to start to get much more beneficial effects when it comes to extrinsic and germane load. So to a limited extent, tools like GitHub Copilot Chat can store information for you. If you look at some of the tools that index your entire code base and have some kind of semantic knowledge about how it all fits together, it means that germane load is reduced as well. You can say things like, in this file, like we're doing this work, how does that relate to this other part of the application? And because Copilot knows about the rest of the application, and it has some kind of semantic mapping between the different parts, it can start to present information in a way that's much easier to absorb and process. Now, that kind of functionality is getting a lot, it's relatively new, but it's getting a lot better. So to put all of this in concrete terms, right? Let's go back to our example of our online store where we're being asked to add a suggested products based on what's in our cart, right? So imagine like all of the complexity of the working out where the purchases section is and finding that information and how it all fits together, all of that complexity and cognitive load that it requires that we talked about before. Now imagine having an AI tool, hypothetically, where you could explain that task. Say, here's my code base. We've got the checkout page. We want to add a section to this that tells me, some suggested products to add to that cart. How would I do that? Now imagine if your AI tool knew the code base, knew how it all fitted together, and said, well, that means you're probably going to need to change this collection of files in these places, right? You're going to need to look up some stuff in the database. There is a function in there, or there is a function that goes and gets stuff out of the database for previous orders that have a product. You could probably use that. Here's that code. It's in this file. Here is another piece of code that sorts that data and enables you to efficiently put it into collections and give it to you in a format that can be displayed on the page. But then also you need the checkout page, and that's over here. But also you probably want to change the tests for that as well. Here's where the tests live. You've got tests on that checkout behavior. There's some UI tests. You're going to need to change them to make sure there's a new section in there. That's part of the work you need to do as well. And so rather than having to navigate through your file tree to find the bits and pieces that you need, by talking to this AI tool that knows your code base, it's going to start to retrieve that information, that task that you want to do, put it in a form that you understand how it all fits together, and you can start working on it a little bit more directly as an idea rather than a collection of changes to lines of code. Now that kind of stuff, to me at least, sounds extremely exciting. Like I love the idea of being able to get that information and reduce that cognitive load. Now, people are scared about that kind of functionality. Like, if I can do that, why can't the product manager who hasn't actually written code for 30 years, why can't they just ask the AI to do that and then ask them to implement that piece of code? If you want to know the answer to that, I'm doing another talk tomorrow night after some drinks called The Skynet is Falling, during some drinks, called The Skynet is Falling. And so we'll talk a little bit more about that. But as a developer, being able to pull that information dramatically reduces that extrinsic and germane load that I need to be able to do that task, to perform that task. And ultimately, that's what all these AI tools are trying to do, right, is to reduce that load on you. Now, just to close this out, I talked about flow and I've talked about cognitive load. I've talked about cognitive load a lot. I told you I liked that idea. Just to close that loop, ironically, let's talk about feedback loops. And they're not as sexy as AI or the idea of germane cognitive load reduction or design theory, work design theory. But we saw earlier that feedback loops are beneficial for your team's productivity, right? And feedback loops individually can mean that you're doing less work as well. And once again, the tooling can help here. This is where I fall back to my days talking about DevOps all the time. But tight feedback loops that give you useful information, like CI/CD pipelines, automated testing, and things like that, can dramatically improve the state of your feedback loops and improve your happiness as a developer for a start, but also improve the productivity that your company gets out the other side. Right. All right, so I've talked a bit. I just want to summarize like the main things that I was getting at. Right. We're talking about developer happiness, why that matters. So ultimately, the better your development environment, the developer experience is, the more happy your developers are, and the more happy you are, and that directly leads to higher productivity. Now, there are a bunch of different studies I mentioned here. There are some researchers, there are some pieces of research. The one thing that I want to leave you with, just before I give you a slide with resources and things like that, is one other thing that came out of the Good Day project. It turns out that if you put aside 5 minutes at the end of your day before you close everything and go home, if you put aside 5 minutes just to reflect on what you did during that day, that dramatically increases the chance that you are going to walk away feeling like you had a good day. Now, it increases the chances, right? If you spend 5 minutes and reflect on the 47 meetings you had, that's probably not going to give you a good day. But if you do get a chance to sit down and say, well, it felt frustrating, but I actually got these things done, and I made some real progress towards that, that mentally puts you in a position to say, oh, actually, I have had a good day. So that was my suggestion as well. At the end of each day, set aside 5 minutes and think about what you actually accomplished that day. If you want to read more about these studies that we did as well, I've put together a gist of a bunch of those researchers, pieces of research. There's just a whole lot of links in there as well. I'll leave that up for a little bit as well. Actually, I don't need to because it's on the next slide too. So thank you. Stay happy. I have time for Q&A if you want as well, by the way. Cool. Good questions. Everyone's happy? Who's happy now? Who thinks today's been a happy day? Yeah. Oh, that's lovely. All right. Good job. Thanks. See ya.